Now, on the previous video, I explained number 25 by doing substitution method, but in this one, I want to go back and revisit 25 and do linear combinations method. So in order to do linear combinations method, you want your x's and your y's on the left side, and you want your numbers by themselves on the other side of the equal sign. So I'm going to take this top equation, and I'm going to add 3x. It's going to cancel, which due to one side, due to the other, add 3x. So up on top, my top equation will be 3x plus y equals negative 12. Let me write that over here. It's going to be 3x plus y equals negative 12. Now the bottom equation, I'm just going to rewrite it. I can't even see it. Let me see. 2x minus 8y equals negative 86. I'm going to write that one also at the bottom of it. So there's my new system of equations, but now it's lined up. X is on top of x's, y is on top of y's, equal sign on top of equal, and number on top of number. So now let's zoom in on that system of equations. And now I want one of the variables to cancel out. So I could cancel out x's by changing this to a 6 and this to a negative 6. Or I could cancel out y's by changing this y to a positive 8y by simply multiplying the whole top equation by 8. So if I do multiply the whole top equation by 8, I will have 24x plus 8y equals negative 96. And let me rewrite the bottom equation right below it. So there it is, my system now ready to combine and cancel. So the 8y and the negative 8y cancel out. The 24x plus 2x is 26x. The equal sign comes down. And negative 96 minus 86, that's negative 182. So you have negative 182 right there. Final step would be to divide by 26 and divide by 26. If I divide 182 by 26 on a calculator, I get 7. So my answer is negative 7. Now that's my x value. I still need my y value, so I need to plug it back in to any equation I want. I could plug in the negative 7 into the x down here or into the x up here, or I could even go back to my original, anyone at the beginning, and plug in my x value of negative 7 right there. So I'm going to plug it into this top equation on the original, and I'm going to solve for y. So I'm going to plug in negative 7 for x. Check it out. On the top equation, there is the top equation, and I'm going to plug in, like I said, negative 7 for x. So negative 3 times negative 7, that is positive 21, and 21 take away 12 is 9. So my y value is 9. So now I've explained two different methods. First of all, the final answer will be the coordinate negative 7 comma positive 9. So that's the answer for this system of equations on number 25. On the previous video, I explained it by using substitution. On this video, I rearranged the equations so I could use linear combinations. It's up to you to be able to pick the method you feel more comfortable with. Number 26, find the product. That's too easy. That's simply distributing. So let's distribute negative 4r to the 5th times 3r squared. Negative 4 times positive 3, that's negative 12. And r to the 5th times r to the 2nd. You know what? Let me erase that circle because can't see the 5. So r to the 5th times r to the 2nd, that is r to the 7th. And then a negative 4r to the 5th times negative 3r, that's going to be a positive 12 r to the 6th. And last but not least, negative 4 r to the 5th times negative 3, that's positive. Negative 4 times negative 3 is positive 12. And of course, we have no r's, so you just put on that r to the 5th right there. And that's your final answer for number 26. Moving on to 27. Simplify 512 to the 1/3 power. Okay, I could teach you that the 1/3 power is, or I did teach you that the 1/3 power is the third root. But you know what? We're able to use calculators. So on your calculator, simply type in 512, hit the caret button, and then it's going to open up some parentheses. Type in 1/3. That's really 1 divided by 3, close parentheses, and it'll give you your answer. I'm about to do that right now. So if I go 512 to the power of, it opens parentheses, 1 divided by 3, close parentheses, hit equal, the answer is 8. All of that is done with a calculator. The answer is 8. That's it. Okay? So I guess with the Texas Instrument calculators that I have, you do 512, use the caret button. The caret button's right above right below the pi button or above the x squared button on the calculator. And then you type in 1 divided by 3, and it'll give you, when you hit equals, it'll give you 8. But on the Casio, there is no caret button. So there is a button. Let me just draw it right here so you can see what it looks like. You have an X with a little box up here. That's what you would hit instead of the caret button. And then you would type in 1 divided by 3 in the exponent, and it will give you the answer 8. Okay? Numbers 28 and 29 are saying factor the polynomial. Okay? So right from the start, the first type of factoring that you should always attempt to do is pulling out a GCF. Okay? So if we take a look at number 28, with the coefficient 16, coefficient 8, and the coefficient 60, what could you pull out? 4. You could pull out a 4, right? So for sure, let me zoom in a little more. I'm going to pull out a 4. But what else am I going to pull out? Is there anything else in common in all terms? Yeah, there's J, J, and J. So the question is, what is the maximum amount of J's that we could pull out of all terms at the same time? That's going to be J squared. So you have 4J squared. And how about K's? Is there K's in all terms? No. We don't have a K in the last one, so I can't pull out a K. So the GCF is 4J squared. What's going to be left on the inside if I pull out a 4J squared? Well, let's think about this. 4J squared times what gives you back?
4.
Okay, definitely a 4.
4J.
And a J, thank you. But you also need a K in that first term. Because up on top, there's the J to the third K. Yay?
Yay.
Okay, now the next term is going to be, how do you get the 4 times what gets you a negative 8?
2.
Negative 2. So we're going to put negative 2. And how about the J value, the J squared times what will get you a J to the 5th? That'd be J cubed, that's right, or J to the 3rd, whatever you want to call it.
And then K6.
Let's not forget about the K6, K to the 6th. And now for our final term, let's think about this. We have 4 times what will get us a positive 60? 4 times positive 15, right? Yeah. So let's put plus 15, and also, do we need any extra J's right here? No, because J squared, there is no J's, and we have a J squared, so that's it. That's your answer right there, guys.
It's easy.
It's easy, but you need to practice for it to become easier. Okay. So, number 29 is the same type of question. I'm going to skip it. You want me to hold on?
Yeah.
I'm sorry. Number 29 is the same type of question. I'm going to skip it because we already did 28. You guys could try 29 on your own. Of course, if you guys need help, ask questions, all right? But for the video's sake, the next one's done exactly the same. Pull out the GCF and then continue the way we just did. Let's move on to number 30. Find the sum or difference. Okay, so number 30, they want us to add this polynomial with this polynomial. And because there's a plus sign, if you were to distribute a plus sign, nothing changes. So in reality, you don't even need the parentheses. All you got to do is start combining like terms. So let's start with the term with the highest exponent, and let's go alphabetical order. 8x or 8a squared, there is no other a squared, so that's going to be the first part of your answer, 8a squared. Let's go on. Let's move on to the regular a's. Well, right here, there's a 5a. Take away a. How many a's do you have now? 4 a's, and that's a positive 4a, so let's bring down plus 4a. Maybe I should switch colored pens here. And let's move on to the b's now. Well, how many b's are there? Is there any b's? There's a b right here, so let's bring that down. That's a positive b, okay? And we can't combine it with anything else. And then we'll move on to the b squares. Well, there's a negative 2b squared right there, and there's no other b squared, so let me just bring down the minus 2b squared. And also the minus 5 at the very end, this is what's left over, the minus 5, so let's bring that down, minus 5. So that's your huge answer. To be honest with you, I don't remember what order they wrote it in on the answer. It might be like this, with your a squared first, your ab next, and your b squared, and the constant at the very end. But you need to be able to look at all your terms and identify which is your correct answer. Yay?
Yay.
Okay.
Quadratic polynomial, right?
That is a quadratic polynomial, yes. But then again, it has two different variables. So, yeah, that's ugly because there's two different variables, a's and b's. Anyways, number 31. Let's this one you do have to distribute the minus sign. The minus sign right in front of the q squared is going to be a negative q squared. The minus sign right in front of the negative 5 is going to be a plus 5, and that one's a p. The minus sign right in front of the positive 8 is going to be a minus 8p squared. Okay, and there's nothing to distribute out here in the front, so I could just rewrite this one down here. And now I could combine all the terms that are alike. I want to start with the highest exponents. Let me combine the negative 4q squared with the negative q squared. What do I get? Negative 5q squared. And then let's move on to, let's say, p's. I could combine this 11p with this 5p. What do I get? 16p. Plus 16p. What else could I combine? Well, I can't combine anything else, but I could bring down the negative 8p squared, negative 8p squared, and the negative q. I could also bring down the negative q. Normally, I think the computer will group the p's and the q's together. We're not going to do anything else. We could just move things around and make it look a little nicer, like negative 5q squared minus q minus 8p squared plus 16p. That way the q's are together and the p's are together. I mean, but you should be able to see your answer. Even if it's out of order, you should be able to find your answer. It's going to be multiple choice.